Hello, everyone. So somebody commented on one of my videos and asked me to talk about my ISO dim. You may have seen this in my videos. It's a isolation transformer slash dim bulb tester, and I designed it. I did not have a YouTube channel at the time, so I will try to show what I can. But here's a picture of the front, and I'm not going to go into why you might need one of these. I'm going to assume you already know, but if you want to know, I recommend EEV Blog has a good video on it. Uncle Doug has a great video on it. There's a bunch more out there, so I'll link those two below. But we'll start with the schematic. So here's the schematic. I did this in Inkscape, just quick and dirty. I've got the input side here, 120 VAC, double pole single throw for the input power switch. Our transformer here with the 5 amp breaker on the output side. Double pole double throw here. So this is the limit and the bypass switch, right? So up, current runs through the bulb and then out, and then current runs through the limit LED. Down, current runs, bypasses the bulb completely and then out, and then through the bypass LED. And on my output side, I've got the double throw switch, double pole switch, and power out LED with our ammeter here and our voltmeter here, so and our output plug. So this worked pretty well for me. You can add more bulbs, you can add more switches and switch in more bulbs if you'd like. There's all kinds of stuff you can do here, but this is kind of where I landed, and it's worked pretty well. So here's the transformer I went with. It's a Torodial transformer made by Hammond Manufacturing. Not inexpensive, but a very well-made unit. And in parallel, I'm able to get, which is how it's wired, I'm able to get over 5 amps out. In hindsight, this may actually be overkill, but I wanted to make sure I didn't have to worry about that. My output, 625 volt amps there. It's big. These are in millimeters, but it's a big boy, and it's heavy, 11 pounds. So I did reach out to Hammond Manufacturing, who makes the transformer, because I was curious about that inrush current. How much are we talking here? And I wanted to know, should I put my 5 amp circuit breaker on the input side of that transformer or the output side? And this is his response, and I won't go through it all, but he gets into the math a little bit, and the big number here, 487 amps. So that's the inrush. It can be, right? It depends on where you are in that sine wave when you turn that on, but obviously that's a lot of current. And it's only for a few milliseconds, but I didn't want my 5 amp breaker to have to deal with this at all. So that's why I put it on the output side. However, this inrush current did play some tricks on me, and I'll show you a video here. That's not a big deal, not a deal breaker, but kind of a minor annoyance that I have to deal with because I chose such a beefy transformer. So something to consider when you're sizing your transformer. I went with a big one, and it's basically the whole inside of this is that toroidal transformer. Well, they have an inrush current, and it's a lot. It can be upwards of hundreds of amps. And, it's only milliseconds, but this room happens to be on this breaker here, the one in yellow, the arc fault breaker. Well, those are much more sensitive to inrush current. They think it's an arc, right? And depending on where you are in that sine wave, this breaker, when I turn this on, will trip on occasion. So let's see. Oh, there we go. So yeah, not a huge deal. I can turn this off. I can reset the breaker. I'm back in business, but certainly scared the bejesus out of me the first time it happened. And, I could just leave this on all the time, I guess. Don't really want to do that, but just a minor annoyance, but something you should consider. What breaker are you on? Is it an arc fault? How big is your transformer? Things like that. So if we take a look at the bulb here, I chose a fancy bulb. I forget the side I got this on. I think it's 30 watt. So that limits me to 0.25 amps. That's just V equals IR. So, 60 watt limited to a half amp. You can go lower. You'll see designs out there, especially on YouTube. You can switch in multiple bulbs. You can add them up. You can subtract, so you can limit your current as you see fit. I just went with one. But one quick lesson learned is the porcelain here mounted to this. This thing would rock back and forth. The whole, not just the cage, which is loosely on there, but the porcelain itself. And I actually had this on my car, and it had vibrated back and forth so much that the screws, the fastener inside, had come off. So one quick fix was this cork here. So I bought this off Amazon. You can buy, 1 foot by 1 foot sheets. And I just traced it and cut it, and man, it's perfect. It just fills the gaps nicely, and this thing doesn't move at all. And yeah, that was a cheap fix. So on these switches here, these are really nice switches. They are not inexpensive. They're mil-spec'd. I call these out at work all the time in the aviation world. Probably overkill for this, but I'm so used to them. I like them a lot. One mistake I made is the rear end, where the wiring is. I sized for, I think, a single pole double throw and ended up getting double pole double throw. So the back end was bigger than I had anticipated or planned for. These are supposed to go up and down, right? Up is bypass, down is limit, but they could only fit in sideways. So that's why they look like that. Not a huge deal. I would prefer, of course, if you're just from a usability, right? User interface, you flip it up toward the light. You flip it this way toward the light. But, I didn't want to redo the whole panel or the whole box. So I just turned them 90 degrees and we're good there. Also, the panel itself, I ordered a few. Kind of hard to size. I'm not a mechanical engineer, and we're down to the millimeters, and they're supposed to snap in cleanly, and sometimes they do, or they're off. And this one ended up being the one that worked. And it's fine. You can see I run hot out of the wall, 125. I've seen this up to 127, which doesn't affect digital components too much, but it did affect that Heath kit that I did. Because that's all analog and tubes, and 127 is not 115, and it started to make a difference on the output side. So anyway, I got volts and amps, and my limit is 0.25 amps, so this usually stops at 0.2 in the limit mode, but if I switch to bypass, it'll show me my full current. So the bill of materials is on my website. This is the chassis I went with, Tyson silver aluminum. It's pretty big, and for the front panel, I did not cut that myself. I went to Front Panel Express. They have the free software you can download, and it's super cool. You basically put in the dimensions of your front panel, the thickness, the material, and you can lay out all your components, the holes, the square cutouts. You can add text that they'll etch for you. Super easy. I went through a bunch of iterations, until I got it just right. And then you just create an invoice, send them the panel. They'll turn it around in I think it was like a week. It's really reasonable. They're in Seattle, so for me, that's close. That was great. Yeah, can't recommend them enough. They're not a sponsor, just they did a good job. So Front Panel Express, check them out. Here's the transformer again. I've got basically everything on here, so down to the wax string and the bumper feet. So if you see something apart on there in the video or in the photos, it should be on this list. So there is a section on my website for mistakes and lessons learned. I won't go through all of it, but I did mention the cork fix for the porcelain socket wobbling on top. The switches being turned 90 degrees. I also have a quick conclusion here. And I mentioned, I'm not a mechanical engineer. I had never even used calipers before. There was a little bit of metal work that needed to be done, front panel aside. So I'm fortunate. I have a metal shop at work with some very skilled guys and the right tools, and they were able to help me out. It wasn't a whole lot, but things like the bumpers on the bottom, a couple other small things, and they were super generous with their time, and they helped me out there. So you may not need that, and that'd be great. But if you do, maybe reach out to a buddy with the right tools and know-how to help you out. So anyway, that's it for this video. Feel free to steal, borrow the design, go nuts, iterate, innovate, do whatever you like. It's for the world and it's treated me well. And I hope, you learn a few things and you can avoid some of the pitfalls I had. There's some photos on here. Again, the bomb, schematic, some links. I'll tell you what, quick story. This thing's already saved my bacon once. I had a AC cord plugged in to flying leads. I was connected to a transformer on my bench and I wasn't paying attention. And the bulb lit up full brightness. And sure enough, the hot and the neutral on those flying leads right out of the plug had touched. So if this was not connected to the ISO dim, could have been a bad day. But it did exactly what it was supposed to do. Protected me, protected my electronics. And I was able to kill power, rectify the situation, and continue. So hopefully you find this useful. Thanks for watching. Please like and subscribe. And I'll see you in the next one.